Yo, what's up?
Oh, hey. I'm just looking at these cards. They both copy, and I can't tell what to do differently.
Let me see it. Oh, okay, I get it. Like, this one lets you copy it once every turn, while this one lets you copy everything that you've had before each turn.
What do you mean?
Okay, think of it like in Big O. This one works in a linear fashion, while this one works in a quadratic fashion.
Imagine this stack of cards is your input, and this stack is how many steps it takes to find what you're looking for. If your input is 1, and it takes 1 step to get what you want, then the stacks are equal. If your input is 2, and it takes 2 to get what you want, the stacks remain equal. This is like the first creature. The big O is N. You put N in, and you get N out. Input and output remain consistent. However, with the second creature, things go a little differently. You put 1 in, and you still get 1 out. But when you put 2 in, you get 4 out. And when you put 3 in, you get 9 out. The stacks keep getting bigger. The second one gets bigger really fast, though, even when the first one's getting big slowly. Basically, it's an algebra equation where the O is the amount of steps it takes a function to get the input. So if your input is always equal to your output, it's linear, which is a big O of N. You put 1 in, you put 1 out. You put N in, you get N out. However, if your function's total steps is squared value of your input, for example, you put 1 in, you get 1 out, but you put 2 in, you get 4 out, that means your big O is quadratic, represented by big O N squared.
Well, it's also important to remember that in computer science, having a large big O is bad because it means your program is scaling poorly, but in National Gathering, it's actually good because it means you get more cards.
Okay, that makes a lot more sense.
Yeah.
Thank you.